talk about that at the end. So technology must be taken care of. Okay. All right. So Emily Ann, determine the equation of the inverse for the given function and then sketch. Let's sketch this one first. Input, output. What should I plug in first for graphing this? 2, 0 for sure. So you know what I'll do? I'll do a chart going left to right here. So 2, 0. What would be another nice one? And then this kind of tells you what the domain and range. 6 and 6, 2. I can't plug in anything less than 2, correct? You missed one. Maybe that might be nice too to get a little more shape, a little smaller than 6, bigger than 2. But all right, and I do have people I still think that cannot do this, and I don't know what to do for you. I really, Ethan, you're late, and your number got picked twice today, so you're supposed to be doing this. All right, anyway, we're gonna go ahead and graph that. Okay, big, and you can turn off your mic, Emily Ann. 2, 0, 3, 1, 6, 2, and then you should remember asking Emily Ann, can we turn in anything less than 2? And she said no, or plug in. That's because that's what a square root function looks like. It has a starting point, and then goes from there. Reviewing graphing, that's section 4.3. Again, if you can't plug in points, you can't get points on my test. I mean, this is such a basic concept that we're missing. All right, but I should ask Emily Ann this. Emily Ann, turn your mic on again. Because we got an issue when we find inverses. What's the domain of the original? What is the domain of this before we find the inverse of that? Yeah, sorry. Yep, you're right. I shouldn't have put that bracket so fast. Hey, what's the range? Nice. With a uh-huh. All right. And then here's the deal. Domain and range exchange. When I find inverses, we actually have this happen, and I'll show you why this one's a little bit different for the first time that we had this. I know before we restricted the domain, and where was that at? We restricted the domain on this example. It's because x squared minus 9 is a full parabola, and it doesn't pass the horizontal line test. So we had to restrict the domain. So I only had half of this parabola in red, so that when I found the inverse, I only had that square root part, the blue graph, and it still ends up being a function. This is different. This has domain and range issues. What you're going to find out is I have to think about that when I find the inverse. All right. And we'll do that. So Ethan, your number did get picked twice before you have gotten on here. So how do I find the inverse of this? What do I got to do? And this is y already, right? F of x is y. So what should I write in its place now? Equals. And then this is a real basic, maybe a little bit of section 4.4. How do I solve a square root? What do I do, Ethan? Square. And then this is why I went through all of that. Oh, what's the last thing you got to do when we get? Okay, and then we're going to change y to the inverse of f of x, and that really ties these two together. Okay, so, oh, sorry, right in the movie too. It's not COVID. It's just that people can sneeze. It doesn't always have to be COVID. All right, plus 2. Okay, here's the problem, Ethan. That's a full parabola. All right. And this came from the inverse of this graph. So this certainly cannot be a full parabola. So this is what happens. Domain and range exchange. The domain of this has to be the range of the original. So that restricts this to only half of a parabola. So I didn't get that from what we did on Thursday. I got that from this. So it's a true domain and range exchange. a true domain and range exchange where we have to think about those limitations, I guess is what we could say. And then by default, the range for my graph will be 2 to infinity because that was the domain of the original. Okay, so that's another thing with inverses we have to account for. So, and you'll see that because when I plug in 0, I do get 2 input output basic graphing. What I don't want is this. I don't want the full, I missed, dang it. I don't want the full parabola. I missed again. I'm struggling. Okay, anyway, I only want that half that truly is the inverse of that square root. So 1, 3, and look at that. 2, 0, 0, 2, 3, 1, 1, 3, 6, 2, 2, 6. Input output would have given me the same values. I put 2 in, I do get 6 for my new function. And then you can see that this truly is a y equals x reflection. Just that half of the blue parabola, not the full. All right. Okay. Student number, oh man, 1, 1, and then 19, 19. Okay. All right. Emily Ann, what would be the first good coordinate to plug in for letter B? Because we do want to think, what's the domain and range of our original before we find the inverse? You get 0, 0. I shouldn't have to do a chart, right? And then what's the next coordinate I'd plug in? Probably not. Yeah, you tell me, because someone last hour, they did something amazing. Yeah, that's what I was thinking. 2. Okay, be careful. What's 2 times 4? What's the cube root of 8? No, what's the cube root of 8? It works. You just missed something. But then there's a negative. So it's negative 2. So it's 2 comma negative 2. What the student did in the other hour, they did a fourth. That was amazing because a fourth of 4 is 1, and then the cube root of that is negative 1. So they did 1/4 comma negative 1. That was nice. I liked it. All right. What's another one, Emily Ann? So I can get more to this graph and know what's happening. Can you take the cube root of negatives? Yes or no? Ryan, where are you going? All right. Anyway, yeah. So it's negative 2 comma positive 2. All right. And then this is what you need to remember for cube roots. The next one, boy, what would be nice? I don't even know if I could get something that works like 16 probably. The reason I did that, 16 times 4 is 64. So, and then the cube root of 64 is 4. So 16 comma negative 4. I'm trying to give you the point that this kind of flattens out like this. This is our classic cube root look. All right, it's really flat like that. So just got to remember that. So what's the domain and range, Emily Ann? No problems. Okay, so it's all real numbers. So what that means is when we find the inverse, we'll have no problems with domain and range. So yeah, something we got to do with inverses there. Okay, next. Student number 23. Ryan, you back yet? It was like 10 minutes ago. All right, who's the Michael Jordan? Mary. Is Mary here? Got that camera off again, Mary. Okay, how do I find inverse? As we finish off this year strong here, what do we do? Okay, so again, this is why we should be able to do this, because all I'm asking you is what happened in blue in the last one. How do you find inverse? This is y. F of x is the same thing as y. And then what happened in the last one? Nope. We never switched x and y. Yeah, we got to switch x and y. And then, okay, I'm gonna allow you to cube both sides, but then you got to be careful. What is a negative cubed? Because there's a negative still floating in front of that. So it's a negative cubed. It is. So we don't lose that negative. And then it is 4y freed. right? And then what's the last thing you have to do to solve for y? How do you get y by itself? What operation? Divide. Or you can multiply by a fraction. Oops, that's wrong. So multiply both sides by negative 1/4. And actually, that's wrong too, because now I want to turn this into that inverse name. The inverse of f of x that ties these two together equals negative 1/4 x cubed. Hey, just for plugging in purposes. Oh, and by the way, the domain and range, no limits, goes off to infinity and negative infinity. Okay, input output. Mary, in order to graph negative 1/4 x cubed, what do you think the first coordinate you'd plug in for x? Any number. Okay, but pick an easy one. Zzz. Okay, what happens when I plug in 0 for x? What do I get for y? What's 0 cubed times negative 1/4? Input output, Mary. Get 0 for x, I get 0 for y, that's a coordinate. And then look at this coordinate. 1/4 comma negative 1. Hey, what happens when I plug in negative 1? What's negative 1 cubed? What's negative 1 times negative 1/4? So negative 1 comma 1/4. That is the flip or the inverse of this coordinate, switching x and y. And then you'll see that, well, let's just like take this one. This is 2 negative 2. When I plug in negative 2 for x, negative 2 cubed is negative 8. Negative 8 times negative 1/4 is 2. So negative 2 comma 2. These are on top of each other by accident. That is the flip of this coordinate. And then what you'll see for an x cubed is this starts taking off like this. And then this coordinate's red coordinate ends up down here. So this is going to go like this. Ooh, my computer's hot right there where I put my hand. Burn. Okay, and then the y equals x line. We could see that this is, look at this. Okay, reflected all the way across there. Those are reflections of each other. So that's why the domain and range is not an issue with that one either. All right, so know how to do input output. Next, student number 10. Nice, Miranda. Reminding you of graphing. This is section 4.3. Let's graph this first. What do you think you'd input first? What do you think you'd input first on this one as you're writing this down? I'm doing a chart to the left here just to keep it out of the way of the work here. Okay, what would you put in here? Okay, this is the basis of like graphing input output all year long. What number should I plug in for x? What would make that 0 on the inside? What number for x? 1 plus 1 is 2, so I need it to be 0. So I plug in negative 1 for x. Negative 1 plus 1 is 0. What do you end up getting as an output value then? Well, that's here. This is 0, but then I still have all of this. This is how you output. You got to count everything then. So what's 2 minus 0? It's just 2. Okay, so negative 1 comma 2. What should I plug in next? I'm going to make you think about this because we got to get this figured out. We got to figure out how to graphing 101. How am I picking these numbers that I'm plugging in? So I want another number that works out nicely, that's a nice perfect cube root. So what else could I plug in for x? 3 plus 1 is 4. That's not a perfect cube. It's a perfect square. So I want perfect cubes. That's a perfect square again. We need something. We need numbers that are perfect cubes. Something times itself 3 times equals. Okay, I'm going to help you out. I'm going to plug in 0. I'm going to plug in 0. Yeah, we'll get to that later. Okay, what's 0 plus 1? What's the cubed of 1? What's 2 minus 1? And then I'll do that 7. Tell me what you get when you plug in 7. What's cubed of 8? And then what does that become total as an output value? What's 2 minus 2? Okay. And then we got to go the other way. So I'm going to go ahead and plug these in. 0, 1. Because you can take the cubed of a negative. So what would be another value that would work out evenly? If I plug this in for x. Oh, too much. And I want to go negative. Yeah, you're right. 26. This is why this goes crazy. It's going to be 26 comma negative 1. That's why this graph is going to look like this. Oop, I want to restart that. This graph is going to be super flat. But I don't want that. I want to know what happens over here. Okay? So that's why I said plug in a negative, because you can't take a cubed of a negative. So what would be the next nice one that works? No, negative 7 plus 1 is negative 6. And you're missing one. It's negative 2. Because what's negative 2 plus 1? What's a cubed of negative 1? It's negative 1. What's 2 minus negative 1? Oh, 3. Minus a negative turns into a positive. Okay. And then not negative 7, but what gets me a perfect cube? It's negative 9. Why? What's negative 9 plus 1? What's the cubed of negative 8? Negative 2. What's 2 minus negative 2? Oh, he did it again. 2 minus negative 2. 2 minus negative 2. 4. Okay. All right. Now I can graph those. All right. 1, 2, 3, 4. You can turn off your mic. Negative 2, comma 1, 2, 3. All right. And then this is the flat part on the other end. Hey, I missed. I'm going to give that another try. Oh, good enough. All right. Okay. So super flat. All right. Okay. Next, student number 4, Ryan Dunnigan. What do I do to find the inverse? Okay. And then this is y. So just get used to that. So we'll go ahead and do what you said there. What is the next thing that you would do mathematically to solve for y? Nope. Not divide. It's like, if I divided by 2, this would be a mess like this, but then, that doesn't really get rid of that. 2 over 2 is 1, so it's not really accomplishing what you need to do. So what other operation should you do? You are moving the 2 over, but it's not by division. Subtract 2. Okay. So x minus 2 equals the negative cube root of y plus 1. What do you think you do next? Cube. Now, I'm going to tell you the same warning that I told, I forgot who, on the previous question in the notes. What is a negative cubed? It is negative, so you don't lose the negative. And it is a free y plus 1. And it really does need to be written like this because that negative, if we're going to choose a way to keep going, would have to be distributed. I don't think you should do that. What should you do with that negative? Because you're solving for y. What do you think you should do next? How can I get that over on the other side? Through what operation? You actually have two choices. Divide by a negative or multiply both sides by a negative. And really, I would not want you to rewrite this. If you multiply both sides by a negative, this is just all that happens. That negative comes over here. And that makes those parentheses useless. Y plus 1. How do I solve for y now? What do I simply have to do? Subtract 1. And I'm going to leave this like this because, and then I'm going to write it f to the inverse of f of x. And then leave this like this because this is like in like the shifted format of graph this. You can turn off your mic because I'm going to get somebody else here. Student number 12, nice. Ryan Kelty, he's back. Okay, because this is like in a shifted format of what a cubed looks like. Now we're going to see, I think we did graph cubes on accident a couple times, but what do you think I'd plug in first, Ryan, in order to graph this? It's the same idea of what we did with the red graph. What do you think? You're dang right. And we're only going to do a couple, 3 points to get an idea of what's happening. What do you get when you plug in 2? What's the output? You're right. And then did you notice that it's negative 1, 2 in this graph, and this graph has 2 comma negative 1 as a point. That's not a coincidence. That's why these are inverses. Another one, any one would be nice. I guess we could plug in 0 for x, and then I guess that would mean we'd plug in, what did I put it over there? I don't know. Maybe, no, I'll just leave it at that. What happens when I plug in 0? What do I end up getting? I think I went off the grid here. What do you end up? Yeah, go ahead. Sorry. Negative what? Sorry. Nice. Yeah, because 0 minus 2 is negative 2. Negative 2 cubed is negative 8. Oh, I'm sorry. Wait. 0 minus 2 is negative 2. Oh, we made a mistake. Negative 2 cubed is negative 8, but then it's negative. So that's actually 8 minus 1, which is what? 7. And then look, 7, 0, 0, 7. So this is not a coincidence. This is what happens with these, switching x and y. And then that implies, what I'm going to plug in next? Negative 10, 4. I'm going to plug in 4. And then you'll see that you get negative 10 for this. Okay, so 4, 1, 2, 3, 4, comma negative 10, which is off the screen. That proves that this graph looks like this. All right. So another way you could graph these is thinking about switching x and y of our other chart. I mean, that's really what you could do. I could take all these and switch all those x's and y's to get that blue graph as well. All right, I'm not going to write this down. The domain and range is all real numbers for both the original and the inverse. Okay, so graphing both, and then of course, y equals x line, reflections. Okay, those are those points right here. This point's reflected all the way down here. And that's the relationship there. Okay, all right, turn off your mic. All right, now here's a relationship that is true with inverses. And this is why I'm not collecting the homework today for section 4.6, because a couple of those questions were at the end of the assigned homework last Thursday. I told you to do as much as you can with that, which probably was most of it. Wasn't too bad. Composition of functions. Well, first of all, this is just the composition of functions. Looks like this, which equals f of g of x. And then it could be switched. And I just want you to realize that in most functions, these two are normally not equal. You know, and if I did an f of g of x and then I did a g of f of x with the same two functions, f and g, when I switch that composition of functions, I don't get the same result often, hardly ever. But there is one time when you do, and it's when you're verifying if two functions are inverses of each other. Because here's what's true. I'm going to go ahead and write this in sentence form, and you can keep up with me. If f and g are inverses. And this is just something you're going to have to take hold of, memorize, and then use it. All right. If f and g are inverses of each other, then, and this is all I'm going to write, but this is what holds true. Then, okay, it's very unique. It's very strange, but it is true. F of g of x, the composition of those two functions will equal just the variable x, nothing else. Very strange. And g of f of x, the switching of that composition will also equal x. And this is what you're just going to have to accept and prove. In those cheating little apps, those people that use those apps ain't going to help you on this. So yeah, right. I'm bringing that up again because I know it's out there. All right, so f of g of x equals x, and then g of f of x equals x. So that's what you're going to do to prove two things are inverses. I'm going to have to see that work. I'm going to have to actually see you go through that process. All right, let's do number 26. Nice, Patrick. I don't know what this one is. We're, determining the inverses there. Okay, here's our two functions. So take a second to write those down. F of x equals that. G of x equals that. You can read. Determine if they are inverses of each other. And then this is all about the work. So no work, no credit. So you need to prove this to your teacher. So what you're going to have to do is f of g of x and go through that process and see, do I get what I'm supposed to get, x, as a result, and just accept that and move on. So Patrick, what would be the next thing that I write? Be my pen. Tell me what to write as far as going through the process of doing f of g of x. You are correct. So far, so good. F of, what is g of x? It is this. What's the very next thing I should write? Good? Good. So tell me what to write then. Good. You're right. You're right. And maybe you could say the quantity square root of x minus 5 squared plus 5. I'm going to pause for a second and explain, one more time. Wherever there is an x, you replace it with the square root of x minus 5. Very good. All right. And then what four-letter F word describes what I should do? Foil that. You don't just square x and square 5. You have to foil that. And then I'm going to be a quick foiler. Square root of x times the square root of x would happen first. Root x times negative 5 twice. And then negative 5 times negative 5. Getting tired of teaching foiling and showing the two parentheses and showing the 4 lines. We should be able to eventually at some point do this pretty quick. Hey, Patrick, are these inverses? Does this go about what I just said? Yeah. So you stop. This is a failure. This doing f of g of x didn't happen. So that's a good thing for you. You don't have to proceed on and try to look at g of f of x. These are not inverses because I did not get the expected result, which is just x. They are not inverses of each other. They won't have any inverse qualities. All right, moving on. Sweet. Let's look at this next one. All right, let's get a student. We only get a couple more going here. 19. Emily, Ann, we're going to leave you alone. I want to get more people involved. Sebastian, you got picked 15. Okay, Sebastian, use composition. This probably this is probably what we'll have for the directions for the test. I hope, just so that you know. Okay, oh yeah, I got it, the composition thing, as opposed to just proving their inverses. Okay, so Sebastian, start with this. What would I write next? See my pen. Ooh, which is so f of nice, like the verbiage there. What's next? Go ahead. Got it. Nice, nice. Again, good math wording. Oh no, is this going to work or not? Well, does this equal x is what I'm. Yeah, it actually equals x. I did this last hour. I changed. I did some Lexi math. 10-year-old. This is 28 fourths. So -7 plus 28 fourths is 21 fourths. Not x. So again, we got a failure. Wow, this is weird. They're not inverses. Close, but not quite. I hope the last one works. Jeez, we're getting these fails. Okay, good. 17. Is that a new one? 15, 16. Check. Let's see if this one works. And I need to see all this, Jack. I need to see the process. Everyone else too. Okay, next. So tell me what to write. Got it? There you go. Well, I wouldn't do that because you're proving to me, and I could see that your process of logic. So that's I would like to have all that. What happens to the ones then? Or x cubed. And then what's the cube root of x cubed? Hey, and that's kind of section 4.1 a little bit. All right, just the ability to take a cube root of a x cubed, a variable. Hey, check baby, 1, 2, 3. That works. Next, last student, student number 25. Sydney, you almost got away with it. All right, Sydney, g of f of x now. First time we had this work. So now we can proceed on and do the second test. So Sydney, what would this look like? You got it. And then what? Yes, you forgot something. So the quantity cube root of x minus 1 cubed, you forgot something. So wherever there's an x, I replace this x with the cube root of x minus 1. What are you missing? What are you missing? There you go. Okay, so you replace that here, but you forgot the plus 1, part of the rest of g of x. What's a cube root cubed? What happens here? And then you're just left with x minus 1 plus 1, which ends up being what? Check, baby. 1, 2, 3. F and G are inverses. So you just you're gonna have to accept that, memorize it, and then go through the process to prove it. All right. And this is the first time it actually worked and happened that these two are inverses of each other. So if we were going to go ahead and graph them, they'd have the y equals x symmetry. And this is very similar to some of the ones that we already graphed here today, but that's not what you're doing. You're just proving they are inverses through this mathematical f of g of x, g of f of x test. All right. That is it. Let's stop sharing the notes because now we're going to go on to turn it into homework.